19 and problem number 33. It says a particle is moving with an uniform acceleration, is moving with a uniform acceleration along a straight line ABC. Its velocity at A and B are 6 meter per second and 9 meter per second respectively. If AB is to PC is equal to 5 is to 16, then velocity at C that you have to find. So what is that? From A to B, then B to C, it is moving the straight line ABC 6 meter per second. Yes, it is 6 meter here, 9 meter here, and C there is a velocity, let's say V, that you have to calculate, and the distance is in the ratio of 5 into 16, so 5x and 16x we assume. So for the first equation, V is 9, U is 6, and the velocity is increasing. That means that means we have to consider the, because time is not set, so V square, that means 81, U square is equal to 36 plus 2A into 5x. So from here AX will be 45 divided by 10. So this is your first equation. Second equation, same, we will use V square final is equal to A square, this U square is equal to 81 plus 2 into A into 16x. So from here 81 plus AX together I can put this value, so it will be 32 into 45 by 10. So if we reduce 5 9s are 5 2 2 16, so that will give you 81 plus 16 into 9, that is equal to 5 144, that is equal to 225. So V square is equal to 225, so V is equal to here 15 and unit will be meter per second. So at C the velocity will be 15 meter per second. Okay, moving to next problem number 34. A body travels 200 centimeter in first 2 seconds and 220 centimeter in next 4 seconds with deceleration. Okay, the velocity of the body at the end of 7 seconds. So this will be the, so for first 2 seconds it has moved 200 centimeter. Then for 4 seconds it has moved 220 centimeter. And then after another seconds, 7 seconds, you have to find the velocity. So as it is moving, then acceleration and deceleration. So let's say this is v1, this is v2, this is v3, and at the end v4. So now during the first segment of the motion, you can take that the average velocity is v1 plus v2 by 2 into the time. 2 seconds will move the distance. So from here v1 plus v2 is equal to 200. It will be the first equation. So the second, in between this, the average velocity is v2 plus v3 by 2 into 4, that will be 220. So from there v2 plus v3 is equal to 110. And the last one, if I take the total 6 seconds motion, so v1 plus v3 will be the terminal velocities. Average of that, this is by 2 into the time, total time 6, will give you the total distance 200 plus is 420. From there v1 plus v3 sorry, will be 140. So this will be the third equation. This is your second, this is your first. Now from these three, I have to find the values of v1, v2, v3. So if I add these three, so every time I will get 2 of every component of velocity, and all together this is 200 plus 110, 310, 140, that means 450. So if I deduct it, if I divide it by 2, it will be 225. This will be 4 equation. Now one by one I will deduct equation from 4. So if I deduct this, I will get v3. So v3 will be 220 minus 200, that is 25. If I deduct from this the second one, v2, v3, I will get v1. So v1 will be deducting this 220, that means 150. And if I deduct the last one from this one, I will get v2. v2 will be 140, that will be 85. So these are the three things I've got. Then I need to calculate the v4. So first thing I have to calculate the acceleration for that. So acceleration will be v3, any of these two can calculate. v2 minus v1 is equal to a into t into 2. So v2 is equal to, that will be deceleration actually. The v2 is equal to 85, v1 is equal to 115, is equal to 2a. So that is equal to minus 15 acceleration, v2 v1 2 minus v1, that is equal to zeta. So what is the v4? v4 will be v1 is equal to 225, 115, 115 the v1. So this is a. v4 is equal to v1 minus v1 150 minus a into a is equal to 15, because I have already taken retardation, otherwise you have to take 5, and the time is 7. So 115 minus 105, that will give you 10. So the velocity here it will be 10, and unit will be, it is given in centimeter per second. Okay, so that is the requirement of the problem. That's it. Moving to the 35, problem number 35. person running at his maximum speed of 4 meter per second to catch a train. When he is 6 meter from the door of the compartment, the train to leave the station at a constant acceleration of 1 meter per second square. So time taken by him to catch the train. Now you see the condition. The person where it's standing and see the train is apart 6 meter, and he is already moving with the 4 meter per second constant speed, and from there train has also started moving with the acceleration of 1 meter per second. 1 meter per second square. So this is the situation. Let me assume that after the time of t, he may catch the train. So up to the time t, the distance the person will move, the distance the person will move equal to t in the velocity v into t, because he is moving at the constant velocity. This is the first equation. And for the train distance is initial velocity is 0, only he will move with an acceleration of 1 into t square, the time taken, because we are assuming the person has catch the train, so the time taken to reach a same point where both the train and the person will reach with the team. So from these two we can say that t square by 2 minus equal to 4t, or the distance will not be same because they are being 6 meter apart. So whatever the distance come, so this will be the distance dt will be the moved by the train will be lesser than the person. So person will move dt plus 6. This will be the equation. So now if it is the condition, so I put the value, respective value of that. dp is equal to 4t and equal to dt is equal to t square by 2 plus 6. Now if I calculate it, I will get something like that. Minus 8t is equal to 0. This is a quadratic equation, and from there if I solve, I will get 6 2s are, so 6 t minus 6 and t minus 2. This is very easy to calculate. If you try it, you can calculate easily. So there are two values are coming, t is equal to 2 and t is equal to 6. Why two values and what is the justification for that? So let me explain it. So it will be like that. that a person is standing 6 meters apart, so he is chasing the train. Train has also started. So one point of time, as its velocity is high, then only he can reach with, if the train is started moving at acceleration of 1, assuming he has started and reached at point at after t is equal to 2, their first bit at t is equal to 2, where in that 2 seconds train can move up to this, and due to this initial velocity with the constant velocity he may reach there. Then what is the time t6 signifies? Because train has just started with the acceleration, so slowly he will grow up in speed, and it will uh, it will move faster on forward direction. But when the person has touched the first time the train, so due to his velocity is higher, he will move forward to this location, but train will further will pick up the speed, and at point of time he may cross the person. So if I assume that the person, even though it has reached the compartment, he is not able to climb up there, so there may be one situation where the person may go forward, and at point of time the train will again beat him. So in first instance person will beat the compartment, and second instance if it is not made, the train will beat him further. So but in practical sense, once the person for which he is trying to get the compartment, once it is reached, it will automatically climb up there in the train. That is the practical sense. So your practical time would be t is equal to 2 will be the right one, because the later case he will not wait for the later case when he will again cross the compartment. So in first instance, because lesser the velocity, it will be easier to climb up, so he will sensibly will use the time t to when he will reach the compartment. So your practical solution will be t is equal to 6. This cannot be your solution. So in this way your time needed is t is equal to 2 seconds. Okay. So moving to 36, this is not a problem, rather a what it says, what are the kinematic equations rather when motion is under gravity. So this is nothing but different than the linear motion, because in the linear motion there is no effect of the gravity, but when it is a vertical motion there is always a influence of the gravity, because gravitational force is always acting towards downwards. So due to that force there will be a acceleration always, that is equivalent to g, that is nearest value is 9.8 meter per second square. If that is the case, the equation will be similar. If I compare it with the linear velocity v is equal to at, where a is the acceleration, so the similar way when it is against the gravity, it will be v is equal to u plus g and t, and for this v square is equal to u square plus 2as, it will turn into v square is equal to u square plus 2gh, because s is nothing but the height, s is the linear distance. And the third one, basically this was the third one, the second one is this ut plus half at square, that will turn into h is equal to ut plus half into gt square. So this is the motion when the body is falling downwards. That means the acceleration the gravitational this is moving towards the gravitational pull. So that means that case acceleration will also to be considered as positive. In case some object is being thrown upwards or the motion is upwards, so in that case only this equation will be turned into, when for this equation or for this one and this one, when body falls. Okay, when body going upward, this equation will turn into something 2 minus dt v square is equal to u square minus 2gh, and the third one will be h is equal to ut minus half g t square. So only the minus will come when the motion is upward. Okay, so this is the overall equation. There is no much difference, and also the Galileo's trick also can be used for that. That will be h is equal to u plus n minus 1 into a, that means g. You can use it. That is also applicable for this case also. Okay, so this is for now. In the next class or the next chapter, I will move on to the chapter number 20, and the problem number will be 37 onward. Thank you.